Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Heat of hydrogenation, delta_HYD, measures the energy released when an alkene is hydrogenated to an alkane. More substituted alkenes are more stable, lower energy, due to hyperconjugation and inductive effects, so they release less heat upon hydrogenation. Less substituted alkenes are less stable, higher energy, and release more heat. Moving on to the next step. Identify the substitution level of each alkene. Structure 1. Monosubstituted alkene, 1 alkyl substituent on the double bond carbons, example, but 1 Na type. Least stable highest heat of hydrogenation. Structure 4. Disubstituted alkene, 2 alkyl groups, both on the same carbon, i.e., 2-methylpropene isobutylene. Moderately stable. Structure 3. Disubstituted alkene, 1 methyl on each carbon, trans 2-butene type. Similar level to structure 4, but trans isomers are slightly more stable than gem disubstituted in some comparisons. However, internal disubstituted trans alkenes are generally slightly more stable than 1,1 disubstituted. Structure 2. Trisubstituted alkene, 2-methylpent 2-Na, 3 alkyl substituents. Most stable lowest heat of hydrogenation. Moving on to the next step. Rank by decreasing heat of hydrogenation, least stable releases most heat first. Structure 1, monosubstituted, structure 4, 1,1 disubstituted, structure 3, 1,2 disubstituted trans, structure 2, trisubstituted. And for the final step. This gives the order 1, 4, 3, 2, which corresponds to option D. Why other options fail? A and B put structure 2, most stable, trisubstituted, first, which would mean it releases the most heat. Incorrect, it releases the least. C puts 1, 3, 4, 2, placing the 1, 2 disubstituted, 3 above the 1, 1 disubstituted, 4 while close to methylpropene, gem disubstituted, is generally less stable than internal trans disubstituted alkenes in terms of heat of hydrogenation values, but the standard ordering places monosubstituted, gem disubstituted, trans disubstituted, trisubstituted for these specific structures, making option D correct. Therefore, the correct answer is D. Therefore, the correct answer is option D.